Hello, welcome to Designs for the Edge from Microchip Technology. Designs for the Edge is our latest live stream in which we talk about key emerging markets and the technologies that are fueling them. I'm your host, Eric Glatfelter. Joining me in the studio today is Brad Poole. Brad, welcome.
Thanks, Eric.
Why don't you take a minute, please, and tell our viewers a little bit about your role at Microchip Technology.
Sure. I might have the coolest job at Microchip, except for you and the production team here. So I'm fortunate to be on our market segments team, and I lead our efforts to develop our business and our client relationships with machinery companies. So, and by that I mean companies involved in agriculture, construction, and mining. And I think for the purpose of today's discussion, we're talking about smart agriculture and smart farming. So it's really exciting technology. Microchip is well at home with the ability to support the companies and the clients that have big ideas on ways to make, to improve the food supply and find new ways to be more efficient with getting our food, fuel, and fiber.
Excellent.
Yeah.
So we look forward to that discussion. Before we dive into that, just a few logistics. We are live streaming today, so feel free to post questions to your live stream channel, your social media channel, and we'll see if we can get to those at the end of the program. If not, we'll follow up with you afterwards. Also, be sure to like, share, and subscribe as appropriate. So on to our topic today. Again, we're talking about technology trends in smart agriculture. So let's talk about what smart agriculture means. Agriculture, cultivation have been around for thousands of years, obviously getting more complex over the centuries. We're now in an environment where everybody is pretty familiar with what mechanized agriculture means. What's the transition between mechanized agriculture and smart agriculture? What does that really mean?
Well, the easiest way for me to explain is the holy grail in agricultural technology is now individualization. So most people think of farming, they think of a plow and a dirt and a farmer, grabbing a handful of dirt and that's the analysis. But
right.
Today, what we have is the ability for farmers and for people in the food supply to be able to have a relationship and an individualized focus with every seed, plant, tree, animal. And then to take it a step further, to understand exactly what that seed or that plant needs for every stage of its growth process, to really enable it to flourish and harness technology to minimize the footprint on the earth. We call it sustainability also.
Okay, so obviously there's a sustainable impact, but there's got to also be an economic impact,
Yeah.
right? If you're running a farm, whether it's large or small, it's a tight business. So how does smart agriculture help with the economics of agriculture?
Well, as our clients that make tractors and great stuff for smart agriculture know, farmers are probably some of the smartest business people there are.
Okay.
There's just no doubt that they live it. They have to live and breathe it every day. So the ability for them to understand a path to a positive return on investment for every dollar they invest is really important. And the way they get there is just finding that way year on year to increase their yield, spend less money on inputs, and at the end of the harvest season have better success to show for it.
Okay,
Yeah.
so what are some of the trends within the agriculture business that are being developed right now?
So there's a lot of, that's a great question. So autonomy and AI is on the top of everybody's mind, and Microchip is well involved in that. The ability to operate machinery at the edge, so without constant connectivity, if you're on a big field in North Dakota that's miles and miles wide, you just don't have the ability to connect to the cloud or to satellites or to cell phones at all times. So that's very important. So that's driving technology forward that way. Electrification is playing a bit part now as people perfect the use case for electric machinery far away from a barn or an office. More companies are designing products that are fully electric, and that's kind of exciting. Predictive maintenance is something we talk a lot to our clients about, and our clients ask us for support, and the ability to make sure that piece of machinery that's worth $1 million is ready for prime time. Because you basically, when you're in farming, you get the shortest possible window. You get about 2 weeks in the spring when the weather is just perfect, and you have to be running that machinery almost 24 hours a day to make sure that you get all the seed into the field and ready to go for the season. So, and Microchip has got plenty of products and support for that as well.
Okay, so let's talk a little bit more about that. So that time window, right? Obviously, if you delay a couple of days, that's going to have a big impact. So if your machine is not up and ready to go, that's going to have a big impact. And then, if I understand correctly, the activity that machine is going to be engaged in over a short period of time is pretty intense. Do they run night and day or all day long?
Yeah, yeah. When you're talking $1 million pieces of machinery, literally, when you say hours or days, no, the farmer's probably it's a window of minutes that has to be done. If you are able to plant as a farmer on your field that's several square miles and have on the flip side, when the plants are emerging from the ground, if every plant is emerging from the soil within an hour or 2 hour window, that whole field, that they're well on their way to a successful yield that year, because they're maximizing the growth of every single plant.
Okay, and then I assume it's the same when it is time to bring in that yield, right? When it's time to harvest, it's the same thing, running night and day, very short time window.
Yeah, between the weather and the environment, there can be some pretty strict time limitations put on, and you only have, as a farmer, as a small business person, you only have so many hours and so many people and so much machinery you can engage, and you have to make sure that machinery is operating at peak efficiency, and there are systems available through predictive maintenance that will enable that.
Okay, now that time between planting and harvesting is a fairly long cycle, so we have to take care of those plants in between, watering, pesticide, fertilizers. What's happening in that space as far as technology? What does technology enable the farmer to do? So
you might see a headline and it referred to as variable rate technology, and it's like I mentioned earlier, the ability for the farmer to have a relationship with every single plant in that field to reach peak efficiency throughout the entire grow season in real time is really important. And there's all kinds of technologies coming to bear now in 2024 and beyond that are going to help the farmer get there. There is from the tractor planting the seeds in a perfect millimeter position on that field, and then being able to come back and understand just in that specific piece of dirt how that seed did last year, the strain of seed, the variety of seed, where it was placed, how it was placed, the depth, the soil compaction, the conditions of the soil, the number of rainy days or sunny days last year. It all gets taken into account in next year on how you place that seed again.
Okay, and then this technology can also be used to look at the condition of the plant during the growing season.
Yeah.
So
yeah, I was at a client this week, and we were talking about drones.
Okay.
Drones are an emerging technology in agriculture that are allowing farmers to survey at all times, in all heights during the grow season, the condition of the plants. To be able to go out onto a field that's several square miles big, or several square kilometers for those watching in, around the world today, to be able to understand every single plant and understand if that plant needs a little burst of pesticide or water or fertilizer, and able to help that plant flourish, that's really important. And the overlaying theme of this is sustainability. It allows the farmer to increase the return on investment by spending less on input costs. And I heard a number today that a farmer that engages in certain precision techniques can reduce their fertilizer costs on a yearly basis by 60%.
Oh, okay.
If you're using a precision-based planter, you can reach efficiencies, on a $100,000 aftermarket upgrade to your dumb planter, be able to pay off that thing in a couple of years with the increased efficiency you get every year.
Okay. Wow. So you're not only using, conserving water, using fewer pesticides and things like that, but really at the bottom line of the farm, you're saving a lot of money.
Yeah, it's a very copacetic thing, right? You're saving the environment and you're providing a great return on investment for doing it. It's the perfect business.
So we've talked about the large-scale farms. Does some of this technology today, or will it in the future, be adaptable to, think of a specialized smaller farm or an orchard or a vineyard or something like that?
Yeah, absolutely. So the next evolution, as the science and technology gets perfected on the fields of South Dakota, is orchards and vineyards and vegetable farms and fruit farms in Southern California and worldwide. And then the furthering evolution of that will be to be able to take that technology and downsize it to smaller farms around the world, like the smaller plots of land in India and China and Africa, and be able to really benefit from the technology investments that are being made now in the Americas.
Okay, okay, fascinating stuff. So let's talk about really some of the technology underlying all of this. So how important are things like, you mentioned all of the inputs that go into that, like the soil compaction and the moisture and the data from last year and the year before. So there's a huge amount of data aggregation and collection and manipulation here.
Yeah.
It seems like the scale of that is just extrapolating significantly.
Absolutely, and it's got to exist on the edge, as we say at Microchip. You can't be worried about the latency of the information coming from the satellite or the cell phone antennas. So these machines have to be so smart and so technologically advanced that they can make cutting edge decisions right now on a field as they're being pulled 8 to 10 miles an hour down a row of corn, and be able to identify just what that one plant needs in order to help it grow.
Right, so the compute power in that ginormous machine looking at that one plant is pretty significant.
Yeah.
How important, with all this data moving around, how important is security in all of these applications?
Security and encryption are very relevant topics, and thanks for bringing that up. So, but think of it this way, just when you go to the grocery store and you see the variety of fresh vegetables and fruits that are there, that increases every day, and it's fresh and it's ready, and within a couple days you take it home and you can consume it. Well, it also goes hand in hand with the food security and being able to keep the integrity of the food supply intact. So as technology advances, there are malicious intent, malicious players. So being able to track the safety of the food supply at all times is a very important topic. Okay,
and I expect that transitions into asset tracking when you're moving all this stuff around.
Yeah, there are certain clients in machinery that want to make sure that the replacement parts that are installed into the tractor or the machinery are they know where they came from, and they know exactly the quality that they're getting, and that's very important, circling back to being able to make sure that your machinery is ready to go when you need it.
Okay, so I use the term asset tracking. Let me maybe make a not quite clean transition, maybe a little bit of a leap, but let's talk about herds, livestock. Are they tracked as assets now?
Yeah, absolutely. It's a pretty cool thing to be able to make sure that every cow is healthy and happy, and it really translates into just a better food product at the end of the cycle. Being able to understand just through temperature and the amount of water that cow might be drinking, and that's all trackable, and it's all trackable in real time now. So the farmer can employ several different reactionary techniques to make sure that every single livestock is happy and healthy.
Okay, so you can actually look at the environmental conditions of a field, not weather, temperature, precipitation, humidity, what the condition of the food stock is on that field, and correlate that to the well-being of the livestock
in the most humane way possible. And you're basically barcoding our animals to make sure that everyone is happy and healthy.
Fascinating. So okay, so there's a lot of cool stuff, a lot of cool applications going on. Let's talk about some of the main technologies that enable all of this kind of stuff. So the big buckets of technology are, first of all, compute power. So there needs to be a lot of intelligence in centralized locations and on the edge. So what does Microchip offer there?
Microchip's got one of the biggest electronics components portfolios in the industry, so we're doing well with what we can bring to bear. So you just said the compute and the processing. We've got everything from 8-bit supporting parts all the way up to a new family of ours, our 64-bit microprocessors, and that's really helping the evolution of AI, artificial intelligence, and edge making decisions at the furthest ahead possible time you can make that decision.
Right. So, okay, so you mentioned the range of compute, 8-bit to 64-bit, FPGA processing in there.
Yeah.
You also talked about a lot of what are essentially algorithms that we have to do to compare all of this data and optimize it for agriculture. How important are the tools and the software in that space?
Super important. So you bring up a good point, and thanks for that. So I was at a client last week, and it's a client that's making some really cutting edge machinery, and they refer to themselves, despite the amount of steel and the electronic components and the amount of electrical engineers they've got and mechanical engineers involved in the process of making a piece of equipment, they consider themselves a software company.
Interesting.
And it's an amazing a transformation forward for the industry. So Microchip's very cognizant of that, and we've got great tools, great support. We've got teams of people ready to come to help the transformation and evolution of this industry.
Okay, so second big bucket let's talk about, let me ask you about, is communication or networking. So obviously lots of data moving around. What are the significant protocols there, or what are the emerging protocols in that space?
Well, so we Microchip supports CAN, LIN. We also do PCI Express for connecting the boards. Ethernet, many different speeds, bandwidth, capabilities, and length. We've got some really exciting products from our group that's able to run Ethernet out to the far reaches of some of the largest implements you can possibly imagine, and be able to make decisions in real time from a camera, whether that one plant or that one little piece of soil needs something extra.
Right, okay. And then I know we touched on security before, but there are security products, both hardware and software, that support this ecosystem.
Absolutely, and we have it built into a lot of our microcontrollers and microprocessors, the ability to have that level of security and encryption you need ready to go.
Okay, so other areas of significance like power management, signal chain monitoring. I think we talked about a lot of data being collected through sensors. So that all has to be moved around and manipulated. Yeah,
we've got a team of folks that are finding new ways to connect and manage sensors. And really, when you're talking about the size and complexity of the machinery that's involved right now in agriculture, everything has a sensor in it, and everything actually has multiple sensors in it.
Sure.
So to be able to track location and condition and exactly what's going on at all times, to be able to measure the soil from a moving vehicle and be able to make adjustments on the fly, you need some very advanced electronic components to do it. And we've got a team of individuals that just have some really cutting edge stuff that they're putting together.
Okay. Okay, so if you could just wrap it up kind of like at a system level, what do you think the main thought process that somebody needs to go through when they're thinking about this at a system level? What are the biggest obstacles they need to overcome, and how can Microchip help them?
So these are big, complex pieces of machinery, and they have, in many cases, a 3 to 5 year design process. But through that 3 to 5 year design process, you have to make a piece of equipment that's relevant for the next 20 years. If you're a farmer investing in a $1 million piece of equipment, you need 20. It's a generational purchase. It's a generational investment also in a piece of equipment.
Okay.
So Microchip needs to be, we need to understand the complexity involved, not only now, but 20 years ahead, and we got to make sure that that product's available for the machinery companies, our clients, to be able to purchase and put into their products for the next 20 years, and Microchip can do it.
Okay, awesome. Brad, thank you so much for that. Appreciate your expertise in that area. At this time, I'm going to see if we have some questions from our audience today. So feel free to go ahead and ask those in your social media channel. There are a couple queued up. Ali on YouTube asks, what does the development of semiconductor technologies give us for the development of agriculture?
The ability to do more and do more efficiently, quicker, and with an easier design on-ramp, to be able to, as an engineer, have a much better design environment experience. And definitely.
Okay, so there's also a question from YouTube, and I think we touched on this a little bit before, at what stage will the development of drone technology develop in agriculture, And is it doing so now? So maybe you can give us just kind of your assessment of where it is today and where it'll be going tomorrow.
It's accelerating at breakneck pace now. What you can do with a drone. Drones aren't that small little dinner plate size one you can buy at the store anymore. These are almost vehicle size with a 6 to 8 feet wingspan that can haul payloads of 50 pounds or more.
Okay.
So the drone can go operate on its own autonomously across a field several miles wide with minimal operator input. And what that does is it enables you to go out and look at just about every plant at any given time in real time across the field. It also enables you as a farmer to not have to start up that $1 million piece of machinery with that 500-gallon diesel tank and have to just print money that way. You can find a much more efficient way to survey and look at the condition of your field. And we believe this is going to just keep accelerating in smart agriculture.
Okay, so it sounds like the right tool for the right job.
Absolutely.
You're not using a sledgehammer for a precise job.
And Microchip's got some interesting stuff coming forward too, and it will enable us to go out and do, with even smaller drones, to go out and be able to pick up information around the field and be able to relay it back to the main office, the main farm, at any given time on soil conditions, field conditions, and some pretty exciting stuff coming forward.
Okay, great. So let me go to a couple of questions that were submitted before we started the broadcast. Does Microchip offer an edge-ready solution for machinery-type applications?
Absolutely, and we're talking to several clients about it now, and just like we talked about earlier, the ability to make quick, reactive decisions on the example I like to use is a modern planter. Can cover 40, 50, almost 60 rows. Mm-hmm. It's more than 100 feet wide. Right. Every single row is a computer.
Okay.
So every single row needs to make a rapid fire decision based on millimeter accuracy on what needs to occur based on what a edge or artificial intelligence ready camera is telling it to do.
Okay. Amazing. All right. One more pre-submitted. Does electrification make sense for smart farming equipment?
Yeah, electrification's interesting. So yes is the answer, but probably not way out on the far reaches of a field yet. And maybe that's coming down the road. Microchip has an extensive catalog of silicon carbide products that will enable our machinery clients to electrify. I think the trend, to bring it back, is probably more towards the support vehicles, the support tractors, the support robots that are operating around the farm, or municipalities that do stuff like mowing and just basically close-in stuff where you can quickly pull up and recharge as you need.
Okay. All right, one more from social media from Mike. How can these advanced technologies help farmers in less developed parts of the world increase their efficiency and use less volume of chemicals and herbicides?
Yeah, so that's the holy grail again. So an example I can cite on that one is Brazil, the largest soybean producer in the world.
Okay.
Brazil is 5% connected. So literally 5% of the farms in Brazil have any type of connectivity. So what we can help, again, accelerate is the ability to have that edge-ready computing ready to go on the big machinery, the planters, the tractors, the harvesting machines, and have it able to make quick reflexive decisions without that constant need for connectivity. So I think that'll really benefit major producers in the world like Brazil.
Awesome. All right. Again, fascinating area. Brad, thanks again so much for joining us and sharing your knowledge in this area. Thank you to our audience for participating today. Again, please like, share, subscribe as appropriate, and visit us at microchip.com/designs for the edge. There you can see the rest of our episodes for the remainder of this season. So thank you again. I hope to see you next time.